So, over the last couple of lectures, we explored how prototypal inheritance works in JavaScript, and we did that using a couple of different techniques. So we used constructor functions, ES6 classes, and object.create. Now, all of these techniques basically allow objects to inherit methods from its prototype, so to delegate their behavior to their prototype, right? But now it's time to turn our attention to more real inheritance, so in the way that we learned in the very first lecture of this section. So what I'm talking about is real inheritance between classes, and not just prototypal inheritance between instances and a prototype property like we've been doing so far. And I'm using class terminology here because this simply makes it easier to understand what we're gonna do. But of course, you already know that real classes do not exist in JavaScript. But anyway, here is what we're gonna do. So we will create a new student class and make it inherit from the person class that we have been using so far. So person will be the parent class and student will be the child class. That's because student is basically a subtype of a person. So a student is also a person, right? But it is a more specific person. And so this is an ideal child class. Now this is really useful because with this inheritance setup, we can have specific methods for the student, but then the student can also use generic person methods like the calc_h method that we have been using. And that's basically the idea of inheritance that we're going to implement in this lecture. Now, just like before, we will start by implementing this using constructor functions. So in this lecture, we will inherit between classes using constructor functions. And this is going to be a bit of work, but it will allow you to understand exactly how we set up the prototype chain in order to allow inheritance between the prototype properties of two different constructor functions. Then in the next lecture, we're going to do the same thing using ES6 classes, which, as you would expect, is a lot easier. And finally, of course, we will go back to using object.create as well. All right, but enough talk. Let's put this into practice now. So here I already have the person function constructor that we have been working with in the beginning of this section, and also the calc_h method that we set up on the prototype property of person. So this is just a copy of what we already did. And so now let's continue by building a constructor function for the student. So const student. Now usually we want a child class to have the same functionality as the parent class, but with some additional functionality. And so usually we pass in the same arguments, but then also some additional ones. So that's going to be again first name and birth year. And then we will also pass in the course. And so now everything works the same here. So first name is going to be first name. This dot birth year is birth year. And finally, this dot course is going to be the course that gets into the function. So you see that in fact, this student class here has kind of the same data as the person. So it also has the first name and the birth year, but then it has an additional property, which is the course. So now let's actually create a new student. So I'm calling him Mike here. Born in 2020 and studying computer science. And just to make sure, let's log in to the console. And here indeed it is. Let's now quickly add a method as well. So we take the prototype property one more time, and then let's create a method called introduce. And so here we're simply gonna log like an introduction phrase to the console. So for the student to introduce himself. So my name is this.firstname and I study, and then the name of the course. So let's call that here Mike.introduce. And all right, so that works just fine. Great, so far so good. However, there is one thing that we can and should improve here in our student constructor function. So right now, this part of the code here is basically a simple copy of the person function constructor. So of this one that we want to be the parent class, right? And as you know, having duplicate code is never a good idea. First, because it violates the don't repeat yourself principle. But second, and even worse in this case, is that imagine that the implementation of person here changes in the future. Then that change will not be reflected in the student. So instead of having this duplicate code here, let's simply call the person function. So person, and then we pass in first name and the birth year as well. Now, do you think that this is gonna work? Well, let's see, and then I'm gonna explain you why this doesn't work. So the problem here is that we are now actually calling this person constructor function as a regular function call. So we are not using this new operator to call this person function constructor. And so therefore, this function call here is simply a regular function call. And remember that in a regular function call, the this keyword is set to undefined. And so therefore, that's why we get this error here, that it cannot set first name on undefined. So instead of simply calling the person function here, we need to manually set the this keyword as well. So do you remember how we can call a function and at the same time set the this keyword inside that function? Well, we can simply use the call method. So the call method will indeed call this function, but we will be able to specify the this keyword here as the first argument in this function. And so, in this case, we want the this keyword inside this function to simply be the this keyword inside this function here, right? Because, as you know, the this keyword is going to be in the beginning this empty object that is being created by the new operator. And so it is on that new object where we want to set the first name and the birth year property, right? So if we check this now, then it is back to working. And so this is a much better and more robust solution. Okay, so far, this is what we have built. So it's simply the student constructor function and its prototype property, and then the Mike object linked to its prototype. And that prototype is, of course, the constructor function's prototype property. Now this link between instance and prototype has been made automatically by creating the Mike object with the new operator. So all of this is what we had already learned. So this is nothing new at this point, right? Now a student is also a person. And so we want student and person to be connected like this. So we really want the student class to be the child class and inherit from the person class, which will then function as the parent class. So this way, all instances of student could also get access to methods from the person's prototype property, like the calc_h method, through the prototype chain. And that's the whole idea of inheritance. It's that child classes can share behavior from their parent classes. So looking at this diagram, basically what we want to do is to make person.prototype the prototype of student.prototype. Or in other words, we want to set the underscore proto property of student.prototype to person.prototype. And if this sounds confusing, then please just pause the video here for a minute and keep looking at this diagram for some more time. So that's why I created it. Okay? Now, anyway, we are gonna have to create this connection manually. And to do this, so to link these two prototype objects, we are gonna use object.create, because defining prototypes manually is exactly what object.create does. Great, so let's go do that. So let's do what I just showed you on the slide here in our code. And it's important that you do this at exactly this point of the code. Okay? And I will tell you later why that is. So anyway, student.prototype should be object.create person.prototype. And with this, the student.prototype object is now an object that inherits from person.prototype. Now we have to create this connection here before we add any more methods to the prototype object of student. And that's because object.create will return an empty object. And so at this point, student.prototype is empty. And so then onto that empty object, we can add methods like this one. But if we did it the other way around, so if this was after we created this method here, then object.create would basically overwrite this method that we had already added to the prototype object of student. Now, you might be wondering why we even needed to use object.create. So why didn't we just do this? So student.prototype equals the person.prototype, right? This maybe would have seemed a little bit more logical to do. But in fact, this doesn't work at all. And let me actually show you why that is. So if we do student.prototype equal to person.prototype, then we will not end up with the prototype chain that we need. Instead, we would end up with this, which is a completely wrong prototype chain. And that's because here we're actually saying that the student's prototype property and the person's prototype property should be the exact same object. But in fact, that's just not what we want. What we do want is the person's prototype object to be the prototype of student.prototype. So we want to inherit from it, but it should not be the exact same object. And that's why we actually needed object.create. Alright, so let's get rid of this bad code. And here let's just say linking prototypes. And so now with all of this in place, we should be able to do Mike.calcAge, and indeed we get the age of 17. Beautiful. So this worked just fine. And so let's actually now go analyze what exactly happened here. And we already know that this worked because of the prototype chain, but let's see exactly how. So when we do Mike.calcAge, we are effectively doing a property or a method lookup. So that is JavaScript trying to find the requested property or method. Now in this case, as we know, the calcAge method is of course not directly on the Mike object. It's also not in Mike's prototype. That's where we defined the introduce method, but not calcAge, right? So just like before, whenever we try to access a method that's not on the object's prototype, then JavaScript will look up even further in the prototype chain and see if it can find the method, so in the parent prototype. And that's exactly what happens here. So JavaScript will finally find the calcAge in person.prototype, which is exactly where we defined it. And that's the whole reason why we set up the prototype chain like this, so that the Mike object can inherit whatever methods are in its parent class, basically. So in summary, we are now able to call a method that is on a person's prototype property on a student object, and it still works. So that's the power of inheritance. Great. And since we're already here, let's also quickly complete the prototype chain. So just like before, object.prototype will sit on top of the prototype chain. So of course, we could still call a method like the hasOwnProperty method on Mike2. It doesn't matter how far away in the prototype chain a method is. And with this, we now have the full picture of how inheritance between classes works with function constructors. And of course, with ES6 classes, it works exactly the same internally. All that changes is the syntax. So when we do the same thing in the next video using ES6 classes, then keep in mind that it's going to work just like I described here. And so now, just to finish this video, let's quickly inspect all of this also in the console. Let's say Mike.__proto. And so this is, of course, going to be this object here, which contains the introduce method. Right? So this is nothing new, but you see here right in the console that this itself has a prototype too. So let's try this here. And so see the next prototype. And so now this is indeed the prototype which contains the calcH function. And so in fact, that is exactly this object here. Right? And maybe it's even easier to visualize in the console like this. So taking a look at Mike itself, and then Mike's prototype is a person here, which is actually not correct, and we will fix that in a second. So, I mean, the prototype chain, everything is correct, but here it should say student. So you see that right now it says person, but Mike is actually of the type student. Okay, but anyway, here you see the introduce method that we defined earlier. And then if we go even further into this, so not this one, but this one, then you see, of course, the calcH function, which is in the prototype of the prototype, basically, right? So what I said that we need to fix is this. So when we take a look at student.prototype.constructor, then remember that ideally this should point back to the student, right? But here it points back apparently to person. So actually we should use console.dir. And so you see that JavaScript now thinks that the constructor of student.prototype is person here. And the reason for that is that we set the prototype property of the student using object.create. And so this makes it so that the constructor of student.prototype is still person. So we need to fix this because sometimes it's important to rely on this constructor property. And so if we want to rely on that, it should indeed be correct. But that's easy to fix. We can just say student.prototype.constructor and set it to student. But let me just try out some more things here. So just to make sure everything works. So we can again use the instance of operator here. And so this, of course, is going to be true because student is, of course, the constructor function of Mike. But if we try the same now with person, then that indeed should be also true. And so, in fact, it is. And so again, it's because we linked the prototypes together. So if we didn't have this, then this should be false. So of course, Mike.calcH is not a function in this case, because the prototype chain is now not correctly set up to find this method. But let's quickly take this out. And so now indeed Mike is no longer an instance of person. And of course, Mike is also an instance of object because that is also in its prototype chain. All right, so here we just proved that the prototype chain is in fact set up the way that we intended it to be. All right, and that's the end of a very long and, I admit, complex lecture. But I hope that I could still consolidate your knowledge about prototypes and the prototype chain even further, because now you know how to even manipulate the prototype chain yourself manually. And actually, let's now go test if you did actually understand right in the next coding challenge.